Hi folks, Dragoš here from the Senior Dev, and today, together with Bogdan, we're gonna go through a bunch of senior front-end interview questions. These are real interview questions that we've got ourselves in senior front-end interviews, but also our mentees. Number one, we're gonna start talking about tooling, right? And the first question is, can you tell me about your experience using Webpack? What is it used for?
Webpack, it's a module bundler. So we basically use it to put several JavaScript files into a single one. That used to be necessary because in the browser, you basically, in order to add JavaScript, you need to place a script tag for every JavaScript file you have. And when you have a big application with hundreds of files, that's just not practical. So Webpack will kind of bundle all that. It will parse all of them and based on your imports and exports and put them all together into a single bundle. And then we can apply different optimizations. I worked a lot with Webpack in the past, basically setting up projects from scratch and doing all kinds of configurations. Yeah.
Nice, Bogdan. Are you familiar, talking about Webpack and module bundlers, are you familiar with the term tree shaking?
Tree shaking as in Webpack, it's basically what Webpack will do when we ship our bundle to production, and it will basically try to find that code, sorry, modules that maybe we imported in our code, but we're not really using, or parts of modules, and it will basically try to eliminate them so our bundle is as small as possible, and we get the best web performance.
Amazing. Have you used tree shaking professionally in production at any stage? Can you give me an example of that?
Yes. As far as I know, in version 5, it comes by default. So every time we use Webpack, it will try to tree shake our code. One thing you want to be aware of is that it only works with ES6 static imports. So if you have any module in your dependencies or you're using common JS imports with require, then Webpack cannot really tree shake that. So you got to be careful because yes, Webpack ships with it by default, but if we don't use those kind of modules, then it's not capable of really understanding if it should remove that code or it's not being used.
Which modules were?
So ES6 static imports are the ones that do allow Webpack to do tree shaking. In common JS, you know, the old require notation, those ones cannot be tree shaked because they are dynamic and they are evaluated at runtime. So they're basically functions, and Webpack cannot really use them to build this dependency tree and figure out, okay, what's going on in there? Can I drop any of that code until it gets executed in the browser?
Excellent. Seems like you know quite a bit about Webpack. Now, still talking about Webpack and tooling and module bundlers, you know, what is a dependency graph and what is it used for in Webpack?
The dependency graph in Webpack, it's basically what Webpack builds from our entry point. So it will basically take our first file and then figure out and go down all those import statements we have at the top. And from that, it will keep going down until it reaches basically the end. And that's basically a tree structure that it forms. And that's how it stores basically all our modules. And then it's using that to transverse it, to go through it and find out if there's any modules we need to drop or which ones are in production. So it's the kind of the main abstraction in Webpack, and it will always be used to put, you know, to go from individual files to a single bundle.
Cool. Now we're going to move on with a question about CSS in JS. Basically, can you explain what CSS in JS is, and can you give me an example? You know, what are some use cases for CSS in JS?
Yeah, sure. So CSS in JS appeared because we're writing all this JavaScript, and we have a lot of interactivity, and we basically want to change CSS styles when a certain state or a certain variable changes. And CSS in JS allowed us to basically have dynamic CSS, where you click a button and some CSS changes immediately. You could do that with classes, like you would assign a different class to an element, but it's just a lot easier if you could just swap colors or directly do things with JavaScript variables inside CSS. That was not possible before because you had static CSS files. And with CSS in JS, we write our CSS inside JavaScript files, and then Webpack will basically somehow extract that and build different classes and attach them to the JavaScript, to the HTML DOM at runtime, but we don't need to worry about that. So it basically allows you to write your CSS in JavaScript and leverage a lot of dynamic styles. So you have the dynamic language like JavaScript, but you can do styling with it.
Awesome. So you already mentioned some of the advantages, right, of having JavaScript control variables inside your styling. But what are some disadvantages of using CSS in JS?
Well, one of the main disadvantages is that because your styles are now in JavaScript files, you cannot really extract them and do certain optimizations you can do to CSS. And one of the thing is you cannot really cache your CSS files. So if your CSS didn't change back in the days, you could have the user storing that in the browser side because you attach a cache policy with HTTP headers to it, like cache control, and they would store that. And in a subsequent visit, they wouldn't have to download all your CSS. But now
Yeah.
all that CSS, it's inside our JavaScript file, JavaScript bundle. It's all together, which makes our bundle bigger. It's a bit harder to parse, but it's also non-cacheable. You can actually counterfact that by extracting with Webpack your CSS at runtime and ship it separately, but it's still not as easy as it used to be when you had your CSS separated from your JavaScript.
Understood.
It's also harder to debug your CSS because, again, those classes that Webpack generates, they're unique hashes, and all of a sudden, it's not as easy as it used to be to understand why a certain element looks a certain way.
There is some tooling, right, that CSS in JS usually brings on to make that debugging easier. One thing we haven't chatted about is the performance. How does it affect? How does CSS in JS affects performance?
So that's one of the main things is because you cannot cache your CSS, you're loading it, and it will decrease the performance. And yeah, it will also, you might also have a lot of cumulative layout shift because your CSS gets now applied when the JavaScript bundle gets parsed. So in the critical rendering path, we usually evaluate CSS first and we apply it. And that ensures the fact that there's no flash when you load the page. But now because we evaluate this CSS at the end, you might have cumulative layout shift. When the user loads the page, things might move around and you got to be careful. And sometimes split your CSS and ship CSS in JS for the dynamic parts and then still use plain old CSS for most of your grid elements. So you have a stable page. And the other thing is because we are creating new components. For example, I use style components in React. Every time we style a heading or a native React element, we end up creating another component. And in a big component tree, that will create a huge component layer, which it's always a huge component tree, a very deep component tree, which is always a disadvantage because it makes debugging harder. And of course, a bigger component tree, it's also harder for React to re-render all the time. Even if React is very effective, you want to keep it as small as possible.
Awesome, Bogdan. Then we're going to move on to the next question, and we will talk about JavaScript frameworks, specifically React. Have you worked with React in production so far?
Yes, I've worked with React for the last pretty much since 2015. So that will be around pretty much since it came out, yeah.
Awesome. Then you're probably going to fly to these questions. First question is, what is a pure component in React?
Pure component in React. Well, I think so. Pure components used to be when we had class components and you wanted to avoid re-renders, you use one of those because it would compare the incoming props with the existing props, and if they were the same, it would skip the render. You probably don't need it today because we use hooks, and hooks are by default memorized. So whenever you do a set state, React already checks if you are updating the state to the same value, and if that's true, it does not re-render the component. So it kind of comes by default. But back with class components, we had to use pure components.
Cool. Another type of component question is, what is an error boundary component? What is it used for? Why do we have error boundaries components in React?
Yeah, sure. So basically, error boundaries help you limit the impact of an error. So if you have a data fetching error in some component, you can wrap it with an error boundary, and that will, at some level, localize the error so it doesn't go up the component tree and you don't show the whole thing, the whole application broken, but you can actually show a placeholder for that one component that something went wrong. So it allows you to localize and have a much better predictable UI, and also have no layout shift when you have these errors. They can totally destroy the UI if they're not managed.
Awesome. Very well. Now, still talking about React, in this case, we will focus on React hooks. And the hook that we are talking about is, are you familiar with the use effect hook? Tell me more about how is it used? What would be some advantages and disadvantages of using use effect?
Yeah, sure. So we basically use effects to trigger what they call a side effect in React. That would mean when a state variable changes, maybe imagine we want to do something else, like we want to make a call to our analytics system and to tell something changed, or write into local storage, for example. That would be an ideal case for effects. I know when they came out, myself included and all the community kind of abused effects, and we're using them for everything. So we would use effects to change a different, when one state variable change, we use effects to change a different variable. But the thing with effects is that they run after the component re-render and they trigger another re-render. So if you're not careful and you abuse them, you end up having so many re-renders in your component. And of course, re-renders of a parent will cause re-render of a child component. So that will really, it can end up affecting your application if you're abusing them performance-wise.
Second question about use effect hook, it's why can't we use an async function as a callback to use effect?
Well, probably because an async function returns by default a promise, and the return of the use effect hook should always be a cleanup function that allows us to, if we, for example, in the effect attach something to the on scroll effect, to remove that handler. Because if we don't remove it and we end up re-rendering, we keep attaching handlers to that event and we might bloat the browser. So React allows you to return that cleanup function, but when you use async, you're always returning a promise, and React doesn't know what to do with that promise because it expects a function. So that's why you get this linter error, I think, most of the times, that tells you, hey, you cannot use an async function here. Yeah.
Awesome. Totally. Makes sense. We are going to move on with a question about state. Okay. And I want you to imagine that we have a simple front-end application with the following state. Okay. Number one, we will be fetching some data from the backend. Right? Then we perform some user authentication and set some general user settings that will affect those user settings will affect the whole application. And my question is, when we have to deal with such requirements on the client side, what would be the best solution to handle state management in this application, and why?
Sure. Okay, so we have backend. We have data we get from the backend. We have authentication state that you mentioned, and some global settings, right?
Yes.
Okay, so I'll probably place those differently because of the requirements on them. So usually, from my experience, data that comes from the backend can stay in component state unless it's needed by 2 or 3 components, where you could usually just lift it up and you have a bit of prop drilling, but it should be manageable with that kind of data. When you have authentication state, you usually want that to be globally available to any component, because some components might need it to see the user roles and permissions. That's why I'll probably use something like React Context, because it's very useful to broadcast the state to the whole component tree. And for the settings, it looks like there might be some non-trivial state transitions in the settings. Usually, if you have maybe complex transitions, like a user can be premium or not, and that will change many different settings across the app. At least that's what I worked with in the past. In that case, you might look at the state machine, or you might need a reducer pattern. You can, of course, use something like Redux for that, or a smaller, like a Zustand library, but you do need a reducer pattern when you have these complex state transitions. You can use reducer with context. That also works. So that's how I would distribute state, these 3 different ways.
Cool. Now, still sticking with state, one question about essential and derived state specifically. Could you explain the difference between essential and derived state?
The difference between essential and derived state. So basically, essential state would be state that changes by itself, changes independently, and you cannot reduce it any farther. And derived state is state you could calculate based on the essential state. So just to give an example, if you had a component that displays like a breakdown of a shopping cart, all the different items that you add there, they're probably essential state. but the total and the VAT amount, they are derived state, because you can compute that based on all the other items. So that would be an example. And usually you want to keep as little state as possible. So you want to have only the essential state in use state hooks in React.
Amazing. Cool. Now, final question about state and React. What would be the disadvantages of placing state inside React context?
I'd say number one is that if you lift state so far up, anytime that state changes, every component that will be connected to that context will also change. So if you have state that really changes independently and it's consumed by different components, you could also split it in two different React contexts, two different providers, because the components that will subscribe to those will be different. You'll have overall less re-renders. So that's one of the biggest problems. When you lift state in general, but especially when you lift it to context, it will end up causing re-renders. And as a general rule, I try to keep state, or we should all try to keep state as close to where it's being used. Yeah.
Amazing work done. We have a bunch of questions. Two more categories I will be asking you about. We're gonna start with testing, right? And specifically, how would you go about testing a React application? Yeah. If let's think about a mid-sized application, not too big, not too small. There are no tests. Let's say the development team was pretty crazy. They've written no tests. They just, usually happens. We've seen that in companies, but they stitch together a bunch of components. There's data fetching, there's authentication, there's all the kind of functionalities that you find on a client-side application built with React. How would you go? You're hired to bring that up, to implement some best practices, and that one specifically testing. How would you go about testing this kind of application?
Okay, so we have a React application that haven't been tested. I would probably inspect the code base and try to decide either we want to do start with unit test or integration test or end-to-end test, which is the typical testing pyramid. I would probably, in my experience in the front end, one of the best tests to have are end-to-end tests, because you test the features, which is very clear, and then it allows you to refactor your code behind it without changing the tests. And if we have any components that we're reusing, like imagine we might have input fields that are being reused, or buttons, or any kind of component that has ideally some logic and is being reused, like a dropdown, in that case, I would write some unit tests on them. I'm not a fan of unit testing everything, just because in React, you didn't get a lot of value for testing pure components, like just if an image renders. We could do that. Some people do that in order to hit the code coverage. But I would say having some good end-to-end tests, having unit tests on reusable components, and strategically choose some integration tests should be the way to go.
And how do you strike the perfect balance between end-to-end tests, unit test, and integration test in the front end?
That's a very, very good question. I would say you need to understand, if we write a lot of end-to-end tests, but we have, imagine, no unit test and integration test, what will happen is that when your end-to-end test fails, it's good that it's a bug, but it will be extremely hard to go to the code and find exactly where it is. So the more unit and integration tests you have, the easier it is when you find a bug to localize when you make root cause analysis, to localize the bug boundary and really eliminate all the other sides of the application. If you only write end-to-end tests, you will have coverage for your features, but when something breaks, it will still take you hours to debug. So I would say I would be smart about it and understand your application, and then have a certain balance. I cannot give you exact numbers, but I would write a lot of unit tests and a lot of end-to-end tests to finish the feature, to cover the features, and strategically some integration tests on the critical features, like if you have login or if you have payments. You gotta see also like what's more critical in your product.
You did mention the word code coverage when you were talking about unit testing. Can you tell me more about code coverage, like just shortly what it is, and what would be the appropriate amount of code coverage, in your opinion, in a front-end application?
Code coverage, it's the amount of code that executes when we run the test, basically. So people say it's the amount of code we covered with test, but it's the amount of code that actually executes when you run the test. In the front end, I would say it's a bit more tricky than in the back end, where it's a bit easier, but I would try to keep it all the way up to 60% whenever possible. If you go under 60, then it will be quite unpredictable and the tests are unusable because you can't really trust. There's a lot of code that's not tested, so the test might fail, but you don't really know why they are failing. So 60 to 70% would be good. I think going over 80 to 90, it's a bit of an overkill, and you don't get a lot of value from those marginal tests.
In your last team or company, what was the code coverage you were aiming for, and did you have any anecdotes, anything that you can tell us? How did it went for you?
Yeah, sure. So at least in some of my roles, I worked in the finance industry where they made it was a general rule for the company to have around 95% of code coverage. We ended up writing a lot of tests that made literally no sense. You have a lot of files that sometimes are just explicitly declared types. You had to exclude all those, and it was pretty much of a hard measure. Everybody was saying they do TDD, but in the end, everybody wrote tests before pushing their PR. So I'll be really careful with these measures because in the end, people say they would do it and so on. But yeah, I had that experience. I also been in teams that didn't write any tests at all. To be very honest, there was chaos. That was a disaster. And I would say the perfect balance is in the front end 60 to 70. In the back end, I would go a bit more up, 90 to 80, 80 to 90, 95. It's still doable because the backend, again, it's a bit more functional and it's sometimes much easier to unit test or to modularize things than it is in the front end.
Cool. Now, let's talk final category. We will talk about web performance, right? And the question here is, can you explain FCP? Okay, and what are the causes of a bad FCP score?
Okay, so FCP would be the first contentful paint, which is basically the time it takes since the user hits the enter button in the browser to display something and to display anything to them. And usually it's really bad if you ship a lot of JavaScript that is client-side rendered, so it takes a lot of time to parse all this React, bundle, and interpret it for the browser to show something. Or you don't use a CDN, so maybe the assets are not compressed or they're not cached. And so it literally just takes a lot of time to do that. Or you have a lot of CSS. CSS in the header has to be all interpreted before we move on to JavaScript and finally start incrementally rendering the HTML. So if you have a lot of that, it will also take a long time. So these are three causes that I've seen in the past. That's the first thing I would look at.
Let's suppose you take charge of a front-end application, you run your analysis, whatever tool you use, Lighthouse, for example, and you realize that the FCP, it has a very low FCP score. How would you go about fixing it?
So we saw that the FCP is low on Lighthouse. I'll definitely run a couple of analyses just to make sure the score is legit. And once we have that, I'll probably, as I mentioned, look first into the CDN. It's usually the easiest thing to do and gets a lot of benefits if there is not one set. And then probably I would use something to inspect the bundle and see if we can remove any part of the JavaScript that's not being used. And if that doesn't still work, I'll look into code splitting and really only load the JavaScript that you need for a specific page. I'll probably talk to the product managers and see which are the pages that are more critical for us to load fast. Usually it's not all the pages. And I would focus on those ones and code split to make sure that we really load as little JavaScript as possible and maybe defer some of the JavaScript or async load it. You can do that with Webpack. With React.lazy also, you can split your componentry. So basically code splitting would be one of the biggest things I would do after we add the CDN and we make sure we have caching and compression in place.
So number one, CDN, caching compression. Number two, remove whatever libraries that you can remove that are adding way too much JavaScript to the bundle. Number three, code splitting and shipping different chunks of JavaScript as you need them, right, to make that lower. Have you considered, and when do you consider something like server-side rendering? Let's suppose this is a React client-side rendered application, and you've went with all the optimizations, and still, because of the size of the application is too big, and the FCP is way too slow. Would you consider server-side rendering? What would that improve the situation or not?
Server-side rendering, when done well, it will definitely improve by basically showing instantly we ship the render HTML to the client, so they will get something immediately they'll see something. It does add, however, complexity to your code base. So I know in some use cases where people rushed into server-side rendering and then they had to roll it back. I would definitely look at our product, and if the product is very sensitive to loading speed or sensitive to SEO, then you'll get a lot of benefits from server-side rendering. But if it's not, if it's like a SaaS application where it's like accounting software, then there's usually no value in server-side rendering.
So you would stick to CSR still because it's not.
Yes.
Yeah.
Probably in e-commerce, in something like e-commerce or the media where you have a newspaper, they want to load very fast and they're very sensitive to SEO. They're probably most of them using server-side rendering.
Awesome, Bogdan. This was it for today. We covered a lot of topics from CSS and JS to React hooks, to Webpack, to tooling, to testing, and now on to performance. I hope you folks enjoy this. We're going to publish some more series on this. Thank you, Bogdan, for this one, and we will see you in the next one.
See you in the next one.